Hello everyone, my name is Ashish Kumar Pandey and today I am presenting my unsupervised ML project based on mobile price range prediction. The team name is Data Avenger and team members are Ashish Kumar Pandey and Vivek Kumar Soni. Content of the presentation are problem statement, data summary, exploratory data analysis, data correlation, data wrangling, machine learning module, model exploitation, challenges and conclusion. Problem statement. Mobile phone have become great necessity for all individual nowadays. People wants more feature and the best vacation in the phone and at too much cheaper at the cost. The demand of the phone is so high that there is a huge competition prevailing between the mobile manufacturer to stay ahead in the race. These companies try to bring in new feature and innovation so that the people are lured towards buying their brand smartphones. Price of a mobile phones is influenced by different factors: brand name, newness of the mobile model, internal memory, RAM size, connectivity are the some important factors of the price. As a business, it is become utmost priority to analyze the same factor time to time. Hence, through these exercise and our prediction, we will try to help companies estimate the price range competition to other manufacturers, and also it will be useful for customer to verify the price of the mobile. Data summary. The content of the data this feature: battery power, total energy a battery can store in one time, measure in mAh, clock speed at which the microprocessor executed instruction FC and PC, font and the primary camera megapixel, internal memory in gigabytes, M depth, mobile depth in centimeter, mobile weight of the mobile phones, and core number of core processor, px height, width, access memory of megabyte, SCW, screen of a height and width of the mobile, talk time longest in the single battery will last when you are on call, blue, 3G 4G dual SIM, touch screen, Wi-Fi, some support and unsupport categories, EDA, unirated analysis. Our dependent variable price range is equally distributed among the variable. Other discounted features have a equal number of observation for each category except 3G. Here you can see in the pie chart. In the pie chart, you can see the medium cost, the low cost, and the high cost, and the very high cost is equally distributed is among the four. And here is the graphs between the count number of plot which can shows the price variable of these features category except 3G. ED unirated analysis. According to this graph, the count number of phones is equally distributed among all the parameters is every variable except pixel height. The number of phones tend to decrease as we go higher in the pixel height. We can say that the graph is particularly skewed. There you can see in the graph first and the last, you can see the graph is positively skewed. Unirated numerical variable. Here is the graph of a price range. The analysis descriptive stats using counter plot. Here we have performed a different types of counter plot operation regarding the mobile prediction, mobile range. Unirated numerical values. The clock speed with 0.5 GHz stand out in popularity among other phones. Rest of them have equal even distributed over the sales. The phone with higher megapixel camera does not show a great resilience among the customer. All the rest of the feature have shown asymmetric skewness in their scale number except for the screen width. Multivariated analysis. Category variation, almost equal number of observation for each price range for each category. Here you can see in the plot, the graph is plotted between the number of phones and the number of phones in each category with a different kind of different price range according to the blue, green, dual SIM, touch screen, Wi-Fi with 3G, 4G, or like that represented. Multivariated analysis and core and M depth. The core of an less and core is high for 0 and 1 price range. Number 2, count of high and core is high for 2 and 3 price range. Count of phones with less thickness is high and count of phone with high thickness is low. The graph is plotted between the number of phones and the price range grouped by M depth and grouped by N core. Multivariated analysis numerical value. The mean value of a battery power, px height, px width, RAM is decreased with the increase in price. As you can see, when you go for the higher range in our for the RAM, the price will also increase, because in reality when you go for the when the customer want more RAM, they have to pay the higher amount of cost for the phone. So there are the 4 graphs we have plotted. So in this there are the numbers of plot according to the RAM, and you can see in the outlier in the second and the fourth one. Multivariated analysis continued. It's appeared that the values of these values are rise in lockstep with the rise in price. The RAM is having an intermediate effect. The more RAM you have, the more money you will spend. Here you can see the PX, the graphs are battery power versus price range, PX height versus price range, PX width versus price range, RAM versus price range. As you can see in the fourth graph, when you go for the higher one, a higher RAM, the price will also increase exponentially. Data correlation. PX is correlated with PC is correlated with FC. In the data correlation, 3G and 4G are moderately correlated. SCH, we are trying to change into the single variable. PS width and the PX height are moderately correlated. You can see in the PX width and the PS height one, will try to change in the single variable. RAM is highly correlated with our price range, may be one of the most factor is determining the price. Feature selection. The most important feature, as both the graphs are RAM, battery power, mobile weight, internal memory, front camera, megapixel, number of core, primary camera, megapixel, screen height, screen width, talk time. Data wrangling. Here you can see there is a no null values handled outliers in the graph is plotted. Modified px height, ps width and sch and sc width and height in the single column we have plotted. In the battery power, 0 0, these are the null values we have plotted. Machine learning model, algorithm and method to be used to apply predictive modeling, decision tree classifier, random forest classifier, gradient boosting classifier, XGBoost classifier, K nearest neighbor. Machine decision tree, overall accuracy score over dataset is 83%. Prediction accuracy on class 1 is a low cost is 93%. Prediction survey of class 2 medium cost is 81%. Prediction survey on the class 3 is 65%. Prediction accuracy in class 4 is 100%. As a result, we can see that the decision classifier has performed good overall best in class 4. Machine learning model in XGBoost. The overall accuracy of a data set 1 is 92. Prediction accuracy on class 1 is 100%. In class 2 is 84%. In class 3 it is 80%. Prediction in class 4 with a lower cost is 100%. As a result, we can see that the gradient boosting classifier has performed good overall and the best in class 1 and class 2 because it has the low cost. Model selection and validation. Every model we had applied except KNN initially overfitted. Overfitting was tackling using parameter hypertuning. There is a still room improvement for the modeling. Best performance was given by KNN with an accuracy of 0.9 for both training and test set at k is equals to 11. The next best model with the XGBoost classifier which gave accuracy 1.0 and 0.91 for the training and the test set data result respectively. We tried to tuned it, did not solve the problem of overfitting. The best hyperparameter values we can expect it here is confusion metric for the training data set and for the testing set, and a predicted class and actual class you can see here in the matrix. Challenges. The most challenging part in this exercise to find the optimal set of parameters that could give us the best performance. It took hours to try every combination in cross validating and finally selecting the best values. The model could even perform better with even greater final rate. Conclusion. We tried to variety of model and the table above the summarize the result of one of the model. K-Ernest model has a best accuracy of 93%. Optimal accuracy for random forest decision tree, gradient boosting and XGBoost were 85%, 85%, 92% and 91% respectively. However, we will make XGBoost our best model because it provides overall good and individual class accuracy. Thank you.